Now for question 17 of the 2013 calculator paper. This table shows how the mass of barley is related to its volume. So we've got the mass in this column and the volume in this column. For example, if the mass is 30 tonnes, the volume is 50 cubic metres. Or if the mass is 60 tonnes, the volume is 100 cubic metres. A silo contains 105 cubic metres of barley. How many tonnes of barley are in the silo? Pause the video and attempt the question. Now, because we need 105 cubic metres of barley, we can see in the table 100 cubic metres is fairly close to that. So let's look at that. 100 cubic metres is 60 tonnes. Now we still need another 5 cubic metres of barley. Now we know that 50 cubic metres is 30 tonnes, so we'll just write that down as well. So we know that the volume of 50 cubic metres is 30 tonnes, but we only want the volume of another 5 cubic metres. So to get 5 cubic metres, you would divide 50 by 10 to get 5. So you'd do 30 divided by 10 is 3 tonnes. So therefore the volume of 5 cubic metres would be 3 tonnes. So to find 105 tonnes, we can do, to find 105 cubic metres, we can add together 100 cubic metres and 5 cubic metres. So we'll just add these two columns that I'm putting a star next to. So we would add this column, or this row, and this row. So 100 cubic metres plus 5 cubic metres is 105 cubic metres. 60 tonnes plus 3 tonnes is 63 tonnes. So the answer would be 63 tonnes. Now question 18 of the 2013 calculator paper. This is a diagram of a Saturn V rocket or Saturn V rocket. Stage 1 of the rocket was 42 metres in length. Now you can't really see exactly where stage 1 and 2 start and finish. That doesn't matter. What we can see on the diagram is that the length of the entire rocket is 101.6 metres. So it says stage 1 is 42 metres in length. Which of these is closest to the length of stage 1 as a percentage of the total length of the rocket? Pause the video and attempt the question. Now, to find the length of stage 1 as a percentage of the total length, first you need the fraction. Write the fraction that stage 1 is of the entire length. So stage 1 is 42 metres over 101.6 metres. So that's the fraction of the length that it is, 42 over 101.6. And then to change that to a percentage, you just multiply by 100. So we've got 42 divided by 101.6 times 100 is, times 100% is 41.33%. And then rounding that, we can see all these answers here are to the nearest whole number. So rounding that to the nearest whole number percentage, we would get, so we get 41%. So our answer is 41%. And that is because after the decimal point, so we've got 41.3. 3 is less than 5, so we round down. So we keep the 41 as 41. So we're really saying, is this closer to 41% or 42%? It's definitely closer to 41% because 41.5% would be halfway. Now for question 19 of the 2013 calculator paper. A group of 200 Year 9 students was asked which activity they spent most time doing after school, and the results are shown in the table. One of the students is chosen at random, and the probability that the student spends most time doing music practice after school, that's what you have to work out. So pause the video and try the question. Now, make sure you read the question carefully because they tell us that we have 200 Year 9 students. So you don't need to add these all up, but if you did add all these numbers up here from 52 all the way down to 17, you would get a total of 200 students. So if one of them is chosen at random and you want the probability that the student spends most time doing music, we can see that 40 students out of 200 do music. So 40 divided, so we've got 40 out of 200. So remember writing the probability as a fraction. So 40 divided by 200, do music. But notice all our answers are decimals. So you don't want to do 40 ABC 200. You can use the button 40 divided by 200 and you will get 0.2 as your answer. So the answer is 0.2. Now for question 20 of the 2013 calculator paper. Mia shoots an arrow into the air. This graph shows the height of the arrow above the ground level for the time that the arrow is in the air. So for how long is the arrow at a height of more than 2 meters above the ground? You can pause the video and attempt the question. Now, what you might want to do on your exam booklet, or just looking at this question, we can maybe put a nice dotted line showing exactly where 2 meters above the ground is. And the question is, for how long is the arrow at a height of more than 2 meters above the ground? So I'm just going to put these green lines down here showing that at this particular time here, I haven't worked out what it is yet, but that after this point in time, the ball is more than 2 meters above the ground. See, because it's 2 meters, 3 meters, it's a bit more than 5 meters here, and it comes back down, and this, at this time here, is when it's 2 meters above the ground there. So I'm going to put another little green line there. So, just bringing that in. So we need to work out this time difference here. So we're going to have to work out what this scale is. It is obviously not 0.1, 2, 3, 4, 5. That doesn't work. So going up by 0.1s doesn't work. You can try going up by 0.2. So we can go 0.2, 0.4, 0.6, 0.8, 1. So that seems to work. So we've got 0.2 is our first, the scale goes up by 0.2. Another way you can do it instead of guessing and checking like that is to say we've got 1, 2, 3, 4, 5 spaces or intervals between 0 and 1. And then what you do 1 divided by 5 and you'll get 0.2. So each interval or jump from one point to the next is a jump of 0.2. So as we said, we've got, it goes up by 0.2. So if here we've got 3, we've got 3.2, 3.4, 3.6, 3.8. So the next green marked bit there is 3.8. The other way you could have just done that is said 4 minus 0.2 is 3.8. So now to see how long the arrow was at a height of more than 2 meters in the above the ground, you would do 3.8. Take away 0.2 is 3.6. So the answer is 3.6. Now just talking about this graph a little bit, we can see when the ball was thrown that it actually started off at a height of a bit more than 1 meter above the ground. So at time 0, the ball was actually 1.2 meters off the ground. I mean, you can really be asked any sorts of questions regarding this graph. Now for question 21 of the 2013 calculator paper. A cube of side length 2 centimeters, that's this top cube, is glued onto the top corner of a cube of side length 4 centimeters, that's this bottom cube. What is the surface area of the new object? Okay, pause the video and attempt the question. Now, I think the easiest way to do this question would be to work out the surface area of each cube without the 2 cubes being joined, and then subtracting the 2 surfaces that would touch each other. Now, the 2 surfaces that would touch each other would be the bottom of this cube here, but it would also sit on top of an area identical to the bottom of that cube there. So when you look, if I just put this top little block on top of the other block, you'll see that the area that will need to be subtracted is 2 lots of the bottom surface of this small little cube on top. So I'll just bring that down again. So this surface at the bottom, it will sit directly on top of the other cube, but now that surface won't be seen anymore, and neither will that equivalent surface on top of this larger cube. So I'm just going to move this diagram here down the bottom. So like I said, the best way to do it would be to first work out the surface area of each cube separately. So surface area of cube with side length 4 centimeters. Remember there are 6 faces on each cube, and the area of one face is, sorry, we're looking at the bottom cube. Surface area of cube with side length 4 centimeters. There are 6 faces on each cube. The area of this face is 4 times 4, which is 16. So the surface area of this cube is 6 lots of 4 times 4, which is 6 lots of 16, which is 96 centimeters squared. Now, the surface area of this small cube is calculated in a similar method. We've got 6 faces. Each face is 2 centimeters times 2 centimeters. So 6 lots of 2 times 2 is 6 lots of 4, which is 24 centimeters squared. So the total surface area of the 2 cubes, if they're not joined, would be 96 plus 24, which is 120 centimeters squared. I've shown that on this line here. Now, we need to subtract the 2 faces that touch. Now, if I bring this cube back down again, we can see that the 2 faces that touch, sorry, I've made a little mistake here, would be equivalent to 2 faces on the small cube. So it would be 2 faces of 2 times 2, which is 2 times 4, which is 8 centimeters squared. And so the surface area of the new shape is the 120, because we added those 2 together, minus, you'd have 2 times 2 down the bottom there, which is 4, and that would sit on top of 4 centimeters squared as well. So you would take away 2 lots of 4, which is 8 centimeters squared. So 120 minus 8 is the surface area of the new object, which is 112 centimeters squared. So that's your answer. Now for question 22 of the 2013 calculator paper. This table shows attendance at a concert over 4 nights. So we can see the Wednesday, Thursday, Friday, Saturday night and the number of people attending each night. The cost of each ticket was $20. What was the mean amount of money calculated from the ticket sales per night? Mean amount of money, which is the average amount of money. You may pause the video and attempt the question. Now, what you can do is work out the mean or average number of people each night. And to work out an average or a mean, we add all the scores together. So we would add these 4 numbers together. So 310 plus 390 plus 380 plus 420, get a total there and divide that by how many scores there are. And there are 4 scores. So we're adding those 4 scores together, dividing by 4. So we'll get 1500 divided by 4. So the average number of people per night is 375 people. And the average cost, therefore, each night is 375 times $20, which is $7,500 each night. Question 23 of the 2013 calculator paper. Okay, this list shows the heights of 10 students in centimetres, and first height is 155 and the last height there is 180, and there are other heights in between. What is the range of the heights? Pause the video and attempt the question. Now, remembering that the range is the highest score minus the lowest score, so make sure that you look for the highest and the lowest score. So we can see we've got 155 here. You need to check if there are scores lower than that, and 150 is lower than that, and that appears to be the lowest score. So I'm going to circle the lowest score. Make sure that you do that because they don't always put the scores in order. Now let's look for the highest score. This looks pretty big, 180. Let's see if we can find anything bigger than 180. And we've also got 182, which is higher. So looks like 182 is our highest score and 150 is the lowest score. So once again, the range is the highest score minus the lowest score, which is 182 minus 150, which is 32. So your answer is 32 centimetres.